This video should remind you of some things you already know about dimensional analysis, as well as introducing some new ideas with multi-step problems. Let's imagine you have a multi-step problem given cubic centimeters of zinc. Find the moles of zinc. There's no direct connection between cubic centimeters and moles, so we'll break this down into two steps. From your periodic table, you should be able to see there's a direct line between cubic centimeters and grams. That line would be using density. And there's also a direct line between grams and moles. That would be using molar mass. So by breaking it into two steps, each step is clearly defined. Now we can actually do the mathematics. We have to have a given number. Here we've got 5.2 cubic centimeters of zinc as our starting place. So the first thing you'll want to do is write down the given, clearly labeled, multiply by a conversion factor. The conversion factor is set up such that the grams will be the answer. And that means that cubic centimeters must be canceled out in this ratio, in the conversion factor. So if we put cubic centimeters on the bottom, grams on the top, then cubic centimeters will cancel. Grams will survive as the answer. Now we have to tell the truth about what is the ratio between the grams and the cubic centimeters. So for zinc, the density value from your periodic table, 7.14 grams per cubic centimeter. So this is how it's set up correctly. Now it's a calculator problem. So I'm multiplying 5.2 times 7.14, and the answer in my calculator is 37.1 grams of zinc. So this is the first step correctly completed, cubic centimeters converted to grams. For the second step, we'll want to do grams to moles using molar mass. So now I'm ready to do the second step. Now I'm starting with 37.1 grams of zinc. Multiply by conversion factor, and the answer should be moles. The conversion factor, therefore, must cancel out the original grams. So grams goes on the bottom of the conversion factor. Moles should go on the top because that's what the answer is. And now I need to tell the truth. The conversion factor is the molar mass. The periodic table tells you 1 mole, 65 grams of zinc. So that's now the correct conversion factor correctly written. It's all set up to use my calculator. So I punch a few buttons on my calculator and I get 0.57 moles as the answer to the question. These two steps are well done, but they can also be combined into one line if you desire. So this is, I call this the Texas two-step. It can save you some space on your paper. It can save you some time. Start with the given, 5.2 cubic centimeters of zinc. Multiply by a conversion factor. In this case, the first conversion factor will be density. Grams on the top, cubic centimeters on the bottom. Then we can just keep going. You don't have to get an answer. You don't have to stop and say equals. If we continue with grams on the bottom, moles on the top, everything will cancel here except the moles. So see, cubic centimeters cancel cubic centimeters, grams cancel grams. Moles is the only thing that survives. So this is the Texas two-step without any numbers. You can line up conversion factors and carry them through. First conversion factor is the density, 7.14 grams per cubic centimeter. Second is the molar mass. A mole is 65 grams of zinc. To do the mathematics, sometimes people will make errors here. This is trickier because you must multiply by whatever's on the top, divide by whatever's on the bottom of these fractions. So you can see here it should be 5.2 times 7.14 divided by 65. That's the math that I need to do on my calculator to get the answer. So punch a few buttons. Punching buttons on my calculator. 5.2 times 7.14 divided by 65 gets me an answer of 0.57 moles of zinc. Same answer as before, so the Texas two-step hasn't done anything new, but it may be convenient for you. You'll have to decide whether you want to use this method.